Multiplying and dividing polynomials. Let's go. Number one, find the product. That is, by the way, multiplying. So, really, this is a term. This is a term. Multiply the things that correspond. So, 5 times negative 7, that's negative 35. And x cubed times x to the 5th, that is x to the 8th. If you are not remembering why that is, I mean, essentially, if I were to take this and write it in a much more annoying fashion, it would be 5 times negative 7 times x 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 times x. And notice there's 1, 2, 3, 4, 5, 6, 7, 8 of those x's. So see how annoying that is? But it's the same concept. Now we have one term times a binomial, and all that means is we're going to multiply this guy by this term, and we're going to multiply him by that term. So just like this previous one, it's going to be 2 times 3 is 6, w squared times w to the 5th. I'm sorry, I just told you the answer. And the next, I've already kind of drawn this purple line. I guess maybe I should wait just for the sake of thinking through it. What am I going to do next? Well, here we go. 2w squared times negative 5w, that's negative 10 w to the 3rd power. Now we have a binomial times a monomial. But you know how we could rewrite this? In fact, I would not rewrite this. But you could rewrite it with this out front. And if you're like, how am I supposed to do that? I didn't know I was allowed to do that. Well, what is 2 times 3? It's 6. And what is 3 times 2? It's 6. I don't know if you remember, but multiplication is commutative, meaning we can move them around, basically. So I probably would not have done this. And what I would have done instead is just say, hey, listen, I'm going to multiply like this and get negative 10 h to the 7th. And then positive 4 h to the 9th. Now, I would rewrite this because I want it to be in standard form. And if you're like, why is this standard form? Because the 9 is bigger than 7, so he goes out first. Now we're finding the quotient. Okay, so I'm going to do this one time. This 3m is dividing everything up here. How do I know that? Well, I mean, it's got a division line over the whole thing, right? So when I say I'm going to draw this just one time, this is technically what's happening. But we wouldn't really want to write that every time. And then if you think of it in this way, it becomes kind of easier. 6 divided by 3, well, that's 2. And m to the 4th divided by m, well, that's m to the 3rd, right? 9 divided by 3 is 3. And don't forget this negative, he's not going to change. And then m squared divided by m, that's just going to be m. And last but not least, 12 divided by 3, that's 4. Again, negative 4. And m divided by m, the m's cancel. There we go. Now, I see how that, I mean, you can see and I can see how that took a little while. And instead, you could just do mental math and be like, all right, listen, I'm going to divide that. I'm going to divide that. I'm going to divide that, which is what I'm going to do in the next one. So the first thing I'm thinking of is 5z squared, 15z cubed divided by 5z squared. Well, that's going to be 3z. And then after that, I'm going to think about this being divided by this. So negative 10 divided by 5 is negative 2. Z squared divided by z squared is nothing. And then the last one is 25z to the 4th divided by 5z squared. Well, that is going to be positive 5z squared. And just like this one up here, I'm going to rewrite it in standard form. Done. Next. 27 divided by 3 is negative 9c. Negative 3 divided by 3 is negative 1. Done. And welcome to the reason we have been doing star math. Because negative 5 and negative 8, their product is 40, and their sum is negative 13. So, star math, diamond math, I can't. Where's the piece of paper? Whatever. Oh, yep, diamond math. There we go. So if you're like, hey, what does he mean? We haven't been doing this. And yeah, you have. You've been doing this thing. Here, you know what? I'm going to shrink it down and put it right there. Okay, cool. Stay there for me. Because, you know, up here when we had a monomial times a binomial, so we said, hey, I'm going to multiply this guy by him and then by him. Well, check this out. I have a p here. He's going to multiply over here. And I have this p. He's also going to multiply over here. So you know me in color coding. Let's do this. The purples. P times p. That's p squared. And you might look over here and go, p squared, question mark? There's no p squared. Yeah, hang on. And then p times 8. P times negative 8. That's negative 8p. And then, okay, so now we're done with p. Because he has multiplied everybody over here. Next, we are ready to multiply negative 5 times everybody over here. So negative 5p. And negative 5 times negative 8, that's positive 40. And if you're like, okay, I'm still not 100% sure what's going on here, watch this. We admit that p times p is p squared. If you were to combine all of the like terms right here, there's no other p squared, so there's p squared. If you were to combine negative 8p and negative 5p, you get negative 13p. Look, he's right there. And then 40. There's no other like terms for him. 40 plus 40. And look, he's right there. So the diamond math thing is there to kind of help you think through it, okay? Do you have to do this every time? Absolutely not. Could it help? Possibly, right? So like right here, we have, so here, I'll do the diamond thing. Our terms are 1 and negative 2, so if we multiply those together, we get negative 2. If we add them together, we get negative 1. There's a little bit of an issue here, though. This 5 might mess things up, right? So let's just go ahead and do this thing. 5t times t, that's 5t squared. Yeah? Yeah. 5t times negative 2, that's negative 10t. Cool. 1 times t, that's positive t. And 1 times negative 2, that's negative 2. Okay, here we go. 5t squared minus 9t minus 2. Well, looks like we did not end up getting the diamond math perfectly on this one, because that and these just don't quite match up with this, right? But this is correct. This is correct. This doesn't work. This particular version doesn't work when there's a number right there. Kind of like right here, right? So let's slide over here, do this one. I guess really part of the point of this is this diamond thing is useful. Maybe we're seeing some cases where it's not the trick, you know what I'm saying? Because what we're doing is talking about, hey, using the distributive property. All right, so here we go. 4v times v. Hang on, let me back up in case you're like, okay, I think I get it. But let's just double check. This is a binomial, 2 terms. Binomial, 2 terms. So we want to make sure the 2 terms of this definitely multiply everything over here. In fact, it wouldn't matter if it was a binomial times a trinomial, right? If it was 4x plus 3, I'm just whatever, x squared plus 7x plus 7, you would do this. Make sure he multiplies everybody over here, and make sure that he multiplies everybody over here. Does this make sense? Hopefully so. If not, we can talk about it. We can run through it till it makes sense. Let's check this out. 4v times v is 4v squared. 4v times 7 is plus 28v. Negative 3 times v is negative 3v, and negative 3 times 7 is positive 21. So this drops down 4v squared plus 25v plus 21. One thing that might be worth pointing out is how I have been like doing this. I do this like little stair step thing. This is one of those things that like, hey, humans can see patterns and stuff like that. Or not that they can see patterns. We look for patterns, right? If you have problems, if you have binomials that are set up in standard form, meaning there's the variable, and then the next one is going to have a lower degree variable. There's the variable, lower degree variable. Then it's going to kind of perfectly set up this little stair step each time. Now, you might be looking at this one and go, oh no, well, that's not going to work. It's still going to work. It's just in reverse. Lower degree, higher degree. Oh, wait, nope, just kidding. Because this one is higher degree than lower degree, right? So that one doesn't work. Nor does this one. And so, yeah, let's see what that looks like. In fact, I'm going to skip 10 for right now and just do number 11. So here we go. 11. Negative 4 times 7r is negative 28r. Negative 4 times negative 2 is positive 8. 3r times 7r, that's 21r squared. Do you notice how there's no like terms so far? And up here when I was doing it, I did have like terms within the first 3 movements, or the first 3 multiplications, right? I've done 1, 2, 3 here. So anyway, let's keep going. And next, 3r times negative 2, well, that's negative 6r. Now, oh, look, we do have like terms. That's not the point. It's not that you won't get like terms. It's just because they weren't following standard form, it didn't really produce this nice kind of pattern at the end. So, by the way, I was talking while doing that. That's the first term because he has the highest degree. Negative 28 minus 6 is negative 34. And then 8 is just 8. And there we go. Let's see another one that doesn't have, or let's just go back in here. We'll see a nice pattern so we can go, come back to nice patterns. 2p times 5p is 10p squared. 2p times negative 1, that's negative 2p. Those aren't like terms, but check this out. 4 times 5p is plus 20p. Like terms, right? Yes, you can write it right here if you'd like. You will be totally fine to do that. 4 times negative 1, negative 4. But I like doing it this way. 10p squared plus 18p minus 4. Done. 4t minus 9 times negative 6 plus 2t. So I know that I keep doing this thing. I'll just tell you, if I was doing this live and in person with you, I would probably just be using my fingers, and I would put my finger here and then my other finger here, and I go 4t, negative 6. That's negative 24t. And then I go, okay, 4t, 2t. That's 8t squared. Negative 9, negative 6, positive 54. Negative 9, 2t, negative 18t. And then I would just combine them. So this guy's out front because he has the biggest degree. Negative 4t and minus 18t, that's negative 42t. And then plus 54 because he's the only one left. And I just realized that I was supposed to use the table for this thing, so my bad. Maybe we can table it real quick. So the table thing, how that would work is basically you're gonna draw this thing. You're gonna draw a table. Okay, you're gonna have 2p plus 4. You're gonna have 5p minus 1. And then what happens is, here, I'll draw it this way. 5p and 2p connect here. Well, that would be 10p squared. And now we're going to have 5, oops, I wanted to change colors. 5p and 4, well, that's 20p. And next, you'll have 2p and negative 1. Well, that would be negative 2p. And last but not least, you would have 4 and negative 1, which is, oh, I forgot to draw my red highlighter. We can't forget that. Negative 1 times 4 is negative 4. So check it out. That is literally exactly what I had right here, right? All the pieces are there. Here, let me kind of zoom around, change the zooms a little bit. 10p squared, 10p squared. Negative 2p, negative 2p. 20p, 20p, negative 4, negative 4. You add all that up, you get this. So why a table? Just a different way of looking at it. In fact, why would we ever talk about diamond math? It's the same thing. In fact, some people call that like the magic X, just so you know. But let's do another table version, shall we? So we're gonna set up our table. It's gonna have 4 boxes. Why? Because there are 4 terms. Negative 4 plus 3r, 7r minus 2. And then you just connect, right? So 7r and negative 4, that's negative 28r. 7r and positive 3r, that's 21r squared. And let's see, 2 and negative 4, that's positive 8. And let's see, what color have I not used? Green. Negative 2 and 3r, that's negative 6r. Again, same thing, 28, 28, 21, 21, 8, 8, negative 6, negative 6. Combine all that to get this. One more table. So, 4t minus 9. Negative 6 plus 2t. Negative 6 times 4t is negative 24t. Negative 6 and negative 9 is plus 54. Positive 2 and 4t is 8t squared. And let's see, 2t and negative 9 is negative 18t. Did I get the same thing? Well, here's 24t, 24t, negative, negative. 54, 54, 8t squared, 8t squared, negative 18t. There it is. They combine to get the same exact thing. And now it says use the FOIL method to find the product. Well, here's where I go, y'all, if you can do the distributive property, you don't need our friend Mr. FOIL. However, if you find the distributive property to be kind of funky, well then do FOIL or do the table. Again, this is just different approaches. FOIL stands for you do the first 2 terms, you do the outer 2 terms, you do the inner 2 terms, and you do the last 2 terms. So after each one of these, it's the phrase 2 terms. First 2 terms, outer 2 terms, inner 2 terms, last 2 terms. And if you're like, what is going on? Well, let us see. The first 2 terms, this guy's first. So the first 2 terms, right? And now that's z squared. So we'll mark the f. For the f in FOIL, we did it. In fact, here, let's go ahead and write FOIL. So we got it up there for us. The outer two terms, this guy is on the outside. This guy is on the outside. The outer two terms, z and -8, that's -8z. We did it. The inner two terms, this guy is on the inside, this guy is on the inside. I mean, if you're like, I don't see it, think about it. If this is a row of people, he's on the outermost, they're on the innermost, they're in the middle. So anyway, inside 9 times z, that's positive 9z. We did the inner. And then now for last, oh, hold on, I didn't do my little line. There's my line. Now my last is, listen, what numbers have I not multiplied yet? The last terms. They are both last in this line. So by this line, I mean like he's last in this binomial. -8 is last in this binomial. They're also the last two terms we haven't multiplied. So 9 times -8 is -72. You combine all this, you get z squared plus z minus 72. Done. Oh my goodness, we got fractions, but we are going to multiply the first two terms. To get m squared, we're going to multiply the outer two terms. To get positive 4/5 m, we're going to multiply the inner two terms to get negative 2/5 m, and we're going to multiply the last two terms to get negative 8/25. You're going to combine all that, and that becomes m squared, let's see, plus 2/5 m minus 8/25. We don't need to worry about combining anything because we have combined all the like terms. And I did not write the FOIL on here, so I will do it for this one. I didn't know the last one. The first two terms. In fact, here, I know I kind of did my little arches on top and on bottom, so now I'm just going to draw them however I feel. So first two terms, 32, check. Outer two terms, negative 12x, check. Inner two terms, negative 8x, check. Last two terms is that one and that one, positive 3x squared. Now, here's where I'm going to, here, check. Oh, come on, check. There we go. So now I'm actually going to do this. I'm going to go ahead and write 3x squared first, minus 20x next, and plus 32, because we want to write this in standard form. And by the way, part of the reason why we have to do that at all is because these guys weren't written in standard form. So technically speaking, if you wanted to, you could rewrite things to be in standard form before you begin. Might save you 2 seconds later, might save you a lot of seconds later. I don't know. But at any rate, we have the first, the outer, the inner, the last. Here are the first two terms. We get negative 12g squared. Check. We have the outer two terms, which is now negative 18g. We have the inner two terms. I forgot to do my check. Check. The inner two terms are 9 and 2g. That's 18g. That's not a g. That's a g. In the last two terms, which is plus 27. Check. Okay. Combine all that, you get negative 12g squared. Those cancel, plus 27. How do you know they're going to cancel? You don't necessarily know they're going to cancel. Now, coming up in the future, there's going to be times where I'm going to say, that fits a very specific formula, and so we'll know it cancels. Very formula or pattern? I'll let you decide on that one. Next, now I'm going to kind of ditch the FOIL. I'm going to ditch the table, and I'm going to not do any diamond math. I'm just going to use the distributive property, okay? So if you're like, but I love those things, then do them. So I have p times p squared. That's going to give us p to the third power. We have p times 7p. That's 7p squared. We have 4 times p squared. That's 4p squared. And we have 4 times 7p. That's 28p You add all that up and you get p cubed plus 11p squared plus 28p. Next, oh, and by the way, it worked out so nicely because both of those in standard form. Both of these in standard form. D times d squared is d cubed. D times negative 5d, that's negative 5d squared. Negative 2 times d squared is negative 2d squared. And negative 2 times negative 5d is positive 10d. Add all that up and you get d cubed minus 7d squared plus 10d. All right, looking at this, we are writing a polynomial that represents the area of the shaded region. Well, so here we have a square, and a square would be, I gotta select the pen tool to write, x plus 3 times x plus 3. That would be the area of the entire square, but we are gonna get half of that. So here's what I'm gonna do. X times x is x squared. Let's see, x times 3 is 3x. 3 times x is another 3x, and 3 times 3 is 9. And that half is still out there waiting for us to deal with him. Half of x squared plus 6x plus 9. I gotta be honest with you, I would be happy with that. If you want to see it distributed, I mean, okay, it's 1/2 x squared plus 3x plus 9 halves. That's the other right answer. Number 20. Oh my goodness, we have a rectangle and a square. So the rectangle, if we were to do the whole thing, would be this, right? Length times width. And if we were to do just the square, that would be x plus 2 times x plus 2. And here's what we're going to need to do. We're going to need to subtract the red from the purple. We're going to subtract that square from that rectangle. So let's do both of those. How about right over here? So first is 2x plus 7 times x plus 4. All right. This is 2x squared plus 8x plus 7x plus 28. How did I do that? Those two. Sorry. Here we go. These two times these two and these two, right? We would get 2x squared plus 15x plus 28. And the other was x plus 2 times x plus 2. X plus 2 times x plus 2. And this is kind of where that whole diamond math thing comes in, because what's going to happen is the factors of 4 are 2 and 2, and you can add them to get that 4. Fun, huh? So now, like I said, we need to subtract x squared plus 4x plus 4 from that. And what we're going to end up getting is 2 minus 1 is 1. 15 minus 4 is positive 11, and 28 minus 4 is 24. So that is the answer for right here. Okay, cool. Now, finding the product of all these things. This is where I say, listen, FOIL's great. The box thing still works. Then just distributing, finding the product is how I approach these, because here's what's going to happen. You are going to do x times this guy, then this guy, then this guy. Then you're done with him. Then after that, you'll do 10 times this guy, and this guy, and this guy. And then you'll combine like terms, you'll be done. So let's do that. Let's follow the first red. And you know what, here, we'll erase in case you're not feeling it, so we can see it unfold. X times 3x squared. 3x cubed. X times 5x. 5x squared. X times negative 2. Negative 2x. Done with that. 10 times 3x squared. Well, that's 30x squared. 10 times 5x is 50x. 10 times negative 2 is negative 20. Combine your terms to get 3x cubed plus 35x squared plus 48x minus 20. Just that easy. Next, we have, okay, so here's where this can be a little annoying if you have the 3-term and then the 2-term, because over here we had the 2-term and then the 3-term, so we just had like these 2 layers. So technically speaking, if you do it this way, you'll have like 3 layers of numbers, but it doesn't really matter because multiplication is commutative, so you could rearrange them if you wanted to. You could do 3t plus 7 times 2t squared minus 9t minus 5. I'm not going to do that on this one just so you can see and go, oh, okay, I see what he's saying. So let me get rid of this. Go away, go away, go away. 2t squared times 3t. That's 6t cubed. 2t times 7, that's 14t squared. And I'm done with that now. Negative 9 times 3t, that's negative 27t squared. Negative 9 times 7 is negative 63t. Negative 5, I'm done with that. Negative 5 times 3t, that's negative 15t. Negative 5 times 7 is negative 35. So see what I mean? You'd had that double stair step. Whereas on this one, single stair step, but no big deal. So combining all of our like terms and changing colors, here we go. We get 6t cubed. Let's see, that's negative 13t squared. This is negative 78t minus 35. On this last one, I chopped it out and put it down here just because I was kind of running out of room. And now I really would like to rearrange this just for my sanity. In fact, I just realized as I started to rearrange that, I'd like to rearrange it a little further. I'm going to write that piece in standard form right here. And in the other one, since I'm not rearranging it at all, let's just grab him and move him right there. Cool. So, negative 2r times 3r squared, that's negative 6r cubed. Negative 2r times 3r is negative 6r squared. Negative 2r times negative 8 is positive 16r. 5 times 3r squared, that's 15r squared. My little delay in that was just double checking that this guy didn't have an r, because he doesn't. 5 times 3r, that's 15r. And now you can kind of see a little bit of like, oh yeah, make sure and double check, because 15r squared and 15r, you could see getting that a little mixed up sometimes, right? 5 times negative 8 is negative 40. Now, combine it all to get negative 6r cubed plus 9r squared plus 31r minus 40. So, that was multiplying and dividing polynomials. Let me know what questions you got.